Right, this is a electronics board. This is what we use to investigate circuits when we study electricity. It's called the electronics boards because the pieces lock on a board like this. Dead simple. Now the best thing, the thing I like most about electronics boards is the fact that when you build a circuit or make a circuit, it looks like a circuit diagram. So we've got circuit symbols on top. But like I said, when you build a circuit, it looks like a circuit diagram, so I really like that. Right, this is the power supply. Now we're not using cells or batteries in this. We're going to use mains power supply, but this is DC. Okay, it's like an old-fashioned phone charger like this. So that's going to get plugged into the mains. And then that going to get plugged in there. So there's our power supply in place. Okay. Move the label out of the way. Right, let's build a circuit. Let's do what we've done with the FET app, which is where we measured voltage and current in series and parallel circuits. So let's just start with just recap on that. Now let's build the two circuits first. So if we start with a clear board. Have the pieces there. Right, we had two bulbs, didn't we? Okay, so let's have one piece like that. Let's have the power supply like that. Now, okay, that is our series circuit. So, yep, series, because we've got one loop. There's only one path the current can flow. Okay. Right, let's measure current first. Right, think about this. This is an ammeter, this is a voltmeter. They look identical, apart from the fact that they say ammeter here and voltmeter there. So it's quite easy to get them mixed up. We're going to go with current first, so we're going to use the ammeter. Right, the rule for using ammeters. When you connect an ammeter in a circuit, it has to be part of the circuit. Okay, we say the ammeter has to be in series with the circuit that you are measuring. Okay, so that means we have to break the circuit. So if we break the circuit and connect. So when you use an ammeter, you have to make the current, all of the current, flow into and out of the ammeter and then back into the circuit. There we have it. That's how you use an ammeter. So the current at this part of the circuit is 0.22 amps. Okay? We want to measure the current here and the current here, as we did with our. So we have to break the circuit. You have to make a gap and put the ammeter in. 0.22 amps again. And we want the current here. Again, break the circuit because we need to make the current flow into and out of the ammeter and then back into the circuit and back to the power supply. 0.22 amps again. Okay. Right, let's quickly build the parallel circuit. Like this. Okay. So always build your circuit first and then add your ammeter or voltmeter last. Okay, so there we have it. Parallel circuit. So this is two loops. There's two places, there's two ways the current can flow. Two directions. Right, but we're measuring current. We want the current here, 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 and here. Right, let's go here first. We need to make the current flow in and out of the circuit. So, 0.64 amps is leaving the power supply and flowing here. 0.64. How much is flowing here? again, 0.64 is coming back to the power supply. But how much is flowing here and how much is flowing here? So how much is flowing through each bulb? Let's find out. Any predictions? So we need to make a break in the circuit, make the current flow into and out of. So the current here, the current through this bulb is 0.31. The current through this bulb is 0.31. Okay. So as we can see, the 0.64, we're losing a little bit, but yeah, there we go, 0.32. So 0.64 leaves, 0.32 goes this way, 0.32 goes this way. But the two 0.32s come back together here to make 0.64. So there you have it, measuring the current in series and parallel circuits. So let's go back to the series circuit, because we want to measure voltage now, don't we? Okay. So to measure voltage, so with current, which we measure with the ammeter, the current in series it's the same all the way around, but in parallel circuits it's split, or it's shared amongst each route. Right, voltmeter look identical, don't they? This one says voltmeter one. Now voltmeters are different in the way we connect them. We have to connect a voltmeter in parallel. We need to go either side of the thing we're measuring the voltage of. So the voltage across the power supply first. How many volts is this? So 5.90 volts. Okay, 5.90 volts. That's the voltage across the total power supply. Okay. Easy to see. Right, what about this one? This bulb here, the voltage is 2.70. The voltage across here, or 2.74, 2.75. The voltage across here is 3.12. So different, but if we add this 3.14 or 3.10 to the 2.73, these both add up to make the total supply voltage. And then finally, let's build the parallel circuit again. So, voltage in series circuits is shared. Voltage in parallel circuits, can you remember? Voltage in parallel circuits should be the same. So, when you have components in parallel with each other to the power supply, they each gets the full voltage. Each gets the full voltage. So I'll show you that now. There you go. Total supply voltage around about 5.7 volts. This one's getting around about 5.7 volts. This one's getting same as, again, slightly less. Some energy lost, I think, in these wires. Okay, but roughly getting the full supply voltage. Do you notice any other difference between the two bulbs in parallel than in series? Okay, any differences at all? They are dimmer. They're dimmer in series. The reason is, when they're in parallel, each bulb gets the full voltage, so it gets the full energy. There you have it. Measuring current and voltage in series and parallel circuits.